To program, you need to first log on to the KS75 software. I'm logging on now, and I'm going to create a new assembly and show you how to create an assembly from start to end. I will not be able to use any shortcut keys because of the software I'm using, but this should give you an idea of how to program. We're creating a new assembly, so we're going to choose Open Assembly. I'm choosing the training folder. You choose any folder you want. If it doesn't exist, create it with this button here, the new library button. I'm going to create a new assembly. I'm going to call this video. I'm going to say Open. This gives me the shell, or gives me the programming window. At this point, I can now say I want to define how the images are going to be captured. So I go File, Edit Image Positions, and I would type in the dimensions of my board. I double click on the border and type in whatever they are. I'm not sure on this. And we say OK. At that point it will show you the board, show you the tiling. These dimensions are not correct for this board. Use the dimensions as you measure your board. Press OK. I am now going to bring in a stored image. So I'm going to go Image, Load Stored Image. I will then go and find my images. I'm going to bring in one image. And it's giving me a warning that they don't match. I want to use the way the image was captured. The next thing I have to do is stitch my board. So I'm going to go Assembly, Edit Stitcher. The stitcher doesn't exist, so I have to create one myself. To make it easier, I'm going to zoom in on a part of the board. I will then get my stitch tool, and I need to define 3 stitch fiducials. The stitch fiducials can be anything on the board as long as they are unique, and nothing else nearby is going to be confused with them. Once I've picked my 3 stitch fiducials, I will run it, make sure they turn green. I will then uncheck fiducials. I now have to stitch my board, and I want to stitch it getting as much, since this is a KS75, in these small overlap sections as possible, because that is where I'm going to get my warp correction. If I drop stitch points outside, for example here, it will not hurt anything, it just will not be used. The system will only use those stitch points that are accessible or in overlaps. Stitching is something that you should, with practice, you will get very fast at. Make sure that you choose at least 3 stitch points in each row going across. If you cannot find anything, do not pick bad stitch points. Move on. You do not have to get one in each of the big squares. More than 3 is helpful. If one of the stitch points fails, the software will continue on doing the best it can. When you are done, run the stitcher. Make sure it passes and view your results. Anything that's not an overlap will not be used, and you may occasionally have an outlier rejected. If you have an outlier reject, look and see why. It is possible that you pick something with too many things similar nearby. In my case, I'm going to delete this one, and I'm going to drop a new stitch point. I might not have dropped it quite right. Look at my results. Taking a look not only at the numbers here, which should be relatively small, but my motion correction. And if my motion correction is large, 0.2 or 0.3, I know that I have to look into the system to see what might be going on. Everything looks good, so I'm going to save my stitcher, and then I'm going to exit. I have now stitched my board. I wish to now bring in my CAD data. So I will go Assembly, and then I will choose to import CAD. The first thing I have to do is find my CAD file. Select my CAD file, and then I either need to select an existing format or create a new format. For this demonstration, I will create a new format. I have to give this format a name. I have to tell it how the file looks. And if I look at my CAD file, I see that my data starts right away. So I'm going to choose strip lines, tell it to strip 0 lines. My file is variable spaces, and then I need to tell it where my fields are. Part numbers 2, 3, 4, 5, 6, 7. I can then click on my Preview tab, refresh it, and look and see, did it bring in the data correctly, and does my board dimension seem correct? This would be for a single board. I'm going to accept the default structure. I will identify my fiducials, and I will tell it to build. I can then close this window, and it has built my CAD for me. I now need to rotate this board, so I'll edit the task properties, and I'll change the angle to be the angle that I need it to be. If I hit 1 to 1, it will see how I'm lined up. I'm not lined up very well. I'll grab my Move tool, and I will move it into alignment on the CAD. I'm looking primarily at the fiducial, I just need to get it close. I will now resize my task icon to be the size of the entire board. Or in this case, the entire panel. If I zoom out, I will make this task much easier. And this is just a representation of what does a board look like, or the whole panel look like. We'll program an individual board in a moment. Next, I'm going to panelize the board. I select all the components, including fiducials, that belong with the individual board. Do not select the outline for the entire panel. Once I've done that, I will go up to Grouping and choose Panelize Board. I tell it how many columns I have, how many rows I am, my pitch in X, my pitch in Y, whether I'm starting from here and going to here, or which direction I'm going in direction. And I will choose to retain the CAD coordinates as subtasks so that it remembers the CAD coordinates, and if I ever have an ECO, I can just type in the CAD coordinates from the CAD file. Once I hit OK, it then brings this in, and I now have my assembly brought in. The next thing I need to do, now that I've done this, is I now need to edit my layers. So I'll go Assembly, Edit Layers. In here I will now say, is a cloning relationship correct, by looking here at the number of devices. So I have 8 part numbers that are cloned together on this. If any look different, I can say unclone it. I will also, at this point, choose what I want to do pins and text for. In our case, I'm just going to do pins on a few devices just to show you how to do it. Hit OK. Now that I've created my cloning relationship, if I hit search, I will get a list of all of the undefined components. Question mark in says show me undefined. The next thing I want to do, and this is meant to be done very quickly, is I want to double click on the first one, and I just want to roughly define the size of the component. If I'm a little big, that's okay. I just want to make sure I'm going to capture enough image to get the whole part when I do a collect. I would then hit F10, which is Load Next Template. And very quickly I just want to go through and make sure that my blue box is bigger than the part. If I make it the same size and I want my pink box bigger, I just draw it bigger. Remember, pink is your search area. And then I load next template, F10. This is meant to be a very quick operation. Don't spend a lot of time at this point on getting things detailed. All you're trying to do is make sure that you have what you need in order to get the images to program with. We could have cloned some of these ICs together, but since our CAD data didn't clone it, I'm not cloning it at the moment. My fiducial, I'll just make a bigger box for now. Now I'm down to text. I will keep doing the same thing. I need to make sure that my box is big enough to get all the text that I'm interested in. We will define pins later. And then when you get to the end, say no, you don't want to go back to the beginning, just save and exit. And it will just roughly create all of these for you. At this point, it's a good idea to save your assembly. So I'll save my assembly. Now that we've got everything loaded in, rough size, we want to load a sequence. I'm going to load my sequence by selecting the images. In order for a model to even work, you need at least 5 examples, and 10 would be nice. My board is a 10-up panel, but you do not always have that luxury. So you would select multiple files, multiple images that you'd acquired on the machine, and tell it to open those. You now have an image sequence, multiple images selected. At this point, you can tell it just to go start collecting examples of all these different parts for you. I haven't defined a fiducial, so it's not going to line up exactly right, but I will get images from both sets of boards. When it is done, the first thing I'm going to define is my fiducial. So I'll select my fiducial and double click on it. At this point, when we define components or we define anything, I'm going to be much more careful about defining it. So I will draw my task box very similar in size to the part. Now I will hit build. If I don't like the geometry, I can edit my model here and make changes. For example, I know that this should be square, so I'll click on geometry and I'm going to make it square. Now, since this is a round fiducial, I do have the ability now to set round search areas. So I could select this search area or active area, remove it, and create a round active area around my fiducial. By holding the Shift key, that will lock me in to a square, and I will create my fiducial, and I will tell it build, and it will build with the round active area. I can also set my property so that I tell it that it has four-way symmetry, and then save and exit. If I had wanted, when I was in the model, it is possible to auto-align also. Auto-aligning with one example and four-way symmetry, it will do a better job of finding the center of the circle. In my case, it shifted it by about 44 microns. I now need to give it more examples. And you see, because I had small image patches, I wandered off of the pads. Mine didn't line up when I brought in the CAD. I can also bring in the production set, which is the example from all the boards. If I tell it to inspect, I can pick the best examples, making sure they're lined up well, and tell it to add those to the model. I can then re-inspect and see what I have passing and failing. Now my search area is small, so many of these are failing because the fiducial falls outside of my search area. So I will just expand my search area significantly larger. Fiducials often need large search areas because it uses this to lock on for the CAD. I have one example that's not passing. I make sure it's lining up, and I can add that to the model if I want. I see that they all pass. I can save and exit now. Now my fiducials will line up, and if I were to rerun it, I'll get better examples of my parts. Before I do that though, I want to make sure that I wipe out any old training sets. So I'll go training sets, select all of them, and delete. And then I will tell it to start collection again. This time the fiducials will lock on, and because of that it will adjust the CAD appropriately, and my examples will be more closely aligned. Now we want to take a look and define all these components. Keeping the question mark in, I'll hit search again, make sure I get all my undefined components. I will double click on the body of the first component. Now when we draw our task icon, we're going to be much more careful in making the alignment. You can draw the blue box or the task icon to include the solder joints on small components. The box is a task indicator which tells you what you're searching for. You can then resize your search and tolerance box to be appropriate. If your customer is running IPC 610C Class 2, that means that the part is allowed to be 50% off the pad this way or this way. So this brown box would have to be double the size of the blue box and height in this case. And width, it could extend from pad end to pad end. Once I've drawn my box appropriately, I can hit build. It will then bring in all the examples from this board, or if I tell it load production set, it will give me all the examples from both boards, or all my boards. I then want to select good examples. I want to make sure if they have solder joints that the solder joints are good. I line them up carefully as need be. Here. And I tell it to add it to the model. Make sure the examples you add are good examples. I'm just randomly picking different ones off the board, making sure I have good ones. As you add more examples, you will see that the software does a better job of locking on the component as you get more. And by the time you get 5 examples, you may find some of them start passing. At this point, it is appropriate to hit inspect and let it inspect all the parts. After it inspects all the parts, it will present to you and show you how many passed and how many failed. There are various reasons for failing. For example, this part is turned up. That is a bad example. I do not consider it acceptable, so I will not add that to my model. And if I look, I see that has a probability of 10 to the minus 17th that it's what I want. Now it's sorted by probability now. I can also sort by failure. And by sorting by failure, I can now take a look and see why did it fail. And I see, oh, I got a little close. I don't have many fiducials on this board, so I know that I may have a slight problem with alignment. Adjusting that, set everything fine. If I'm happy with the way this model is working now, I would then go File, Flag is defined, Load Next. And I would go through and set up each of my components in this fashion. This grid means component not defined yet. Draw my box. Adjust my search area as need be. Build it. Find some examples to add. If need be, adjust my search and tolerance a little bit. And the box that you draw representing the component is anything you're comfortable with, whether it be the part and the pad or just the part. As I do an inspection, I find that I have many that passed and many that failed. Okay? And I can look through and using various tools, I can add a few examples if they look good. Reinspect. If you're doing solder joint inspection, you need to make sure that the solder joints are good on the parts that you add. I'm getting closer. I see this one here is a damaged component. I want to make sure that one is always going to fail. I can tell it to add that to the bad set so that later if I do changes to the model, I can come back and verify that that one is still bad. Now if I look, this one's failing with 10 to the minus 50. This one's at 10 to minus 22. So there's a big difference between the two and what it considers acceptable and not acceptable. Now if I look, these are failing out of position. So again, I don't have many fiducials on the CAD data. In fact, I only have one fiducial per board. So I'm making my tolerances a little loose just to show you how to do this. Once I'm done, I will flag this as defined and load the next one. This one's an IC. I will do IC slightly different. I'll draw my task icon to be the size of the body. Let me zoom in a little so you can see this better. And now I will use my two-way symmetry tool and I will draw a box that gets the shoulder of the leads and a little bit of the body. My goal is to create a two-way symmetrical active area, because I don't care about the whole body. The part that tells me the position is where the leads come out of the body. If need be, I can adjust. Okay. I'll build it and then I'll adjust my tolerance as need be. You can inspect, it'll look at all these. They'll all fail. I'll pick the best several and add them to my model. Now I have many that passed and many that failed. On those that failed, I can see that one of the active areas is in brighter red. That's telling me that that's the area of problem. If I hit the animate button here, I will see flashing pixels that indicate the problems that it sees at different levels. I can stop that. And let me just add some of these here. I know I didn't have that many solder defects on these boards. The parts look good. I have all but one passing. When I see it's not found, I'm going to add it. I'm now up to the point where I've done all the bodies. It's now time to do the text. I'll select the text button here before I do that, and then I will select the important part of the text that I wish to verify. Draw a box around that and tell it to build. I then need to go get more examples, just like I did for everything else. Make sure you add only good examples of normal variation. When I'm done, I will again flag as defined, load next, find the text, select the appropriate part, highlighting it. If I can't see, I can adjust the contrast and the light intensity to make it easier for me to see. This does not change how the system works. This is just for my benefit as I try to build my text. Again, I add only good examples. If you have bad examples, them failing is okay. It is possible that you allow too much variation. Flag is defined, load next. I'm just verifying each time that it is lined up right before I add it. When I'm done and happy with it, I move on. When I'm at the end, I'll save and exit. Now I have done the basic programming for all the parts and all the text. And if I do a search on the undefined, I see that my pin layouts are left. If I select one of my pin layouts, I'm going to double click on it. I'm going to zoom back on this part. The first thing I want to do is resize my icon to be roughly the size of the part to the end of the leads. I then slide it around and align it where I need be so I'm centered over the part. Now that I've got it lined up over the center, I'm going to go insert, and I'm going to insert, in my case, dip pins because this is a dual inline package, an SOIC. It brings up the Composite Layout tool, and I have to tell it a number of things. I can measure the pitch, or I can enter the pitch if I know it. I will show you how to measure it. Normally I would enter in the pitch. How many pins are on a side? In my case, I have 7. They are not vertical, so I might not have that checked. And on SOICs, I do not create a box locator. I will now measure my pin 1. And I can just make that the size of the pad for now. I can adjust it later if I want. And I'm going to measure my pitch. To make it easy to measure the pitch, I can zoom in, click my pin measurement or pitch measurement tool, click on the edge, for example the edge of the pad, scroll across and choose the edge of the pad on the very last one. We'll then calculate the pitch. And it splits it out and should look right across everything. If you don't want to calculate or you don't want to measure it and you know it, you can just type in here the known pitch. And it will put it in. Whichever way you prefer, you can do. When you're happy, just hit OK. And it will create the alignment. Now I need to define these pins. So I will select one of my pins, double click on it, and I have one example already. It shows me what it was like when it defined it. If I want, I can edit the model, and I would recommend editing the model. And I'll go to geometry, and I'm going to draw a new task icon. And my task icon is just going to be the size of the foot. I'll then create an active area that anchors it, that gets a little bit up, gets both sides of the pad. and I'll hit build. I can then save and exit, and now I can start looking at various examples, and if they're lined up and have good solder joints, I can add them to the model. It is not uncommon to need many examples when you're dealing with solder joints. Always make sure they're lined up good. Before you add them. And when it passed, I'll just inspect and see how I'm doing. I had one pass and a bunch fail. I'm going to expand my search area a little. Again, remember, I do not have good fiducials on this example. I will add a bunch of examples all at once. You may need 70 or 80 examples before it works well. Alright, I'm getting close. Again, I'm checking that all these solder joints are good solder joints before I add them in. If there are any bad ones, I do not add them. That one's a bad one. Not happy with that. If I'm happy with them, I add them. When I'm done, I'll save and exit, and I can inspect it the whole part. And see how I'm doing. If I'm happy with it, I can save and exit. It's also possible for me to then edit the template properties for that and say that that one under General is defined. And I would proceed through all my pin layouts the same way. Now we want to search on our undefined parts. We find that since we've done our pin layouts and we flagged those all as defined, we now have our components and our assembly that are not defined. What we want to do is make a couple minor changes on each of these components. I'll open up each one in turn, and I will resize the task icon representing the component to be the biggest task, the biggest box. And then I will flag it is defined. And I'll move on to the next one. This is meant to be a very quick process. If you grab something off center like I did, we want the task icon to appear centered. When I flag it as defined, I can also say the task icon should be about 0, 0. If I leave this open, when I close it and I open the next one, you'll see that it remembers that that was open and will open it automatically for me. Just a little time-saving device in case you don't want to keep opening and closing it. The only thing left marked as not defined is the assembly. I can edit its template properties and set that to defined. There are a couple other things we should do before we consider ourselves done. We should go to the assembly properties and make sure that we have stitch first on. We also want to make sure that everything else is set up. If we need any changes, for example barcoding, we'll set that up here. We will now go to training options under assembly training options, and we will tell it we're going to train by adding to the production set, and we're going to collect all the failures that the operator disagrees with. We want to make sure those two are set up. We also want to make sure that we got rid of any training sets that we had created now, so that we don't think that they're errors when we find them later. So I'll just select them all, delete them, confirm I wish to delete them. I will save my assembly, and I will now synchronize it so that everything here is available to the system. It says I have a bunch of new things. I'm going to synchronize, and my program is done. It's the initial programming. I would have to go in production, possibly add some examples, fine-tune some of my models, but you've done all the initial programming at this point. You can close it, take it to the production floor, work with it, run for a while before you turn it over.